Okay, hi. Well, let's get started. We're going to talk about reviewing some factoring things first. I have found the past couple of semesters that I've been at East Georgia State that the thing that people are really struggling with is just being solid with their factoring. So we're just going to start with that today. Here are the main factoring ideas that I'm going to go over. I'm going to briefly go over these things and give you a few examples. These are all ideas that you've been taught in previous classes before, and I expect that you already know. This won't be a typical lecture. This will be a lot of me just running through problems so you've got refreshers and problems you can go back and take a look at. So let's just start off with the greatest common factor. And just to remind you, the greatest common factor is the largest number or expression that can be taken out of every term. So if we have something like 3x squared minus 6x, we can take a look here and see that 3 and 6 both have a factor of 3, and we have 2 x's here and 1 x there, so we know we can take out a total of 3x. When we factor 3x out, that is the same thing as dividing, so it's like us writing this up underneath real carefully here. So if we take a 3x out of a 3x, we're left with x, and if we divide a 3x out of a 6x, we're left with a minus 2. Another example here, if we had 6y cubed plus 3y, we can see here that we've got a common, again, of a 3 and a y here. So if we pull 3 and a y out front, if we were to take a 3y from a 6y cubed, we would be left with 2y squared. And if we were to factor a 3y out of a 3y, we would be left with a plus 1. Now, a lot of times people make a mistake here, and they leave this as a 0, and this is not 0. And a way to ensure that you're doing that right is you can always check, right? You can check your factoring. You can check your factoring by distributing. Distribution does the deal. 3y times 2y squared is 6y cubed, and 3y times 1 is plus 3y. So you can always check your work. That's like the best part about algebra. Okay, let's take a look at a special case. Notice that we were going to take a look at 5 different situations. The first situation is just pulling out a greatest common factor, and that is something that you may or may not have to do no matter what the other situations are. Now, the next situation we're going to talk about is the difference in squares. So the difference of squares. And you need to recognize these problems. They're pretty easy to recognize. First off, they're 2 pieces. Okay, usually when we're factoring things in an algebra setting, there are 3 or more terms in the expression. And here, when we're dealing with the difference of squares, it's only 2 terms. And it's going to be in this kind of form. It's going to be in something that looks like something squared minus something squared. And for us to be able to factor this, if you recognize its pattern, then we can just write the answer without doing much effort. And so the first thing you have to do is you have to rewrite the problem as something squared minus something squared. And in this case, we have an f squared minus an l squared. And so the pattern is the factors are f minus l and f plus l. Again, this can be checked by foiling it back together and multiplying it back together, but I'm sure you've seen that before. So I'm just here to remind you of these things before we get started with the trig. Okay, so let's start off with something simple like x squared minus 100. If we were to rewrite it as x quantity squared minus 10 quantity squared, when we use the formula here, we can see that we have x minus 10, x plus 10. Those are our factors. Let's do another one. 4x squared minus 121. Now, I do find it's always a great idea to rewrite the problem, especially when it is not absolutely direct, to rewrite the problem in this form here, because we need a 2 and an x to get a 4x squared and an 11 to get a 121. So be careful with that. A lot of times math students want to skip steps, and a lot of times that can just bite you right in the rear, especially when we start applying these algebra concepts to things that look absolutely crazy. So I'm just going to encourage you to get off on the right foot here. Let's take a look at another one. 36x squared minus 1. A lot of times students miss this as being the difference in squares because of the 1. Although that's the ultimate squared number. So here we have a 6 and an x, and here we have a 1. So this guy's going to factor 6x minus 1, 6x plus 1. And then I want to remind you finally that with this last example, you should always be looking to see if there is common factors that you can pull out to improve a problem. And if you take a look here, you see that it's 2 pieces, but we are not dealing with squared numbers. 12 is not a squared number, 75 is not a squared number. But we can notice that if we were to take a 3x out of this whole thing, we would be left with 4x squared minus 25, and now we have the difference in squares. So, and we just did this one, but I'm going to do it again. This guy has got a 2x in here and a 5 in here. So those factors are 2x minus 5, 2x plus 5, and then don't forget that we have this 3x from the beginning. Okay, let's move on to the difference in sum of cubes. Let's look at the difference and the sum of cubes. Now, the formula for the difference in sum of cubes works just the same as the difference in squares, so let me write it out here. It's a little bit longer, so I'm going to write it right here. F cubed plus or minus L cubed is equal to F plus or minus L, I'll explain that in a second, times F squared minus plus FL always plus L squared. Now, this is a complex operator, and you follow it along the top or along the bottom. So if we have the sum of cubes, then when we factor it out, we have F plus L times F squared minus F times L always positive L squared. So let's do some examples here so you can see how this goes. Okay, so let me just start off with one kind of simple, x cubed minus 27. So I'm going to rewrite this as this is x cubed minus 3 cubed, and I'm just going to apply this formula here. I want to make sure that you see that this is the F and this is the L. So we're going to get x minus 3, so the sign doesn't change, and then you say the first squared, so x squared. The sign now changes, first times last, always positive last squared. Let's do that again. Let's do this one here. So this is something cubed plus something cubed, and we know the 27 is 3 cubed, and 8x cubed is 2x. So let's crank that one through. Now notice we're going to be going across the top, so it's going to be plus, and then it's going to be changed to minus, and then it's always going to be plus. There's a little acronym for this, and it's SOAP. Same, same, opposite, always positive. That's the pattern that you always have with this. Okay, so this is going to be 2x plus 3, sign says the same, times f squared, so 2x times 2x is 4x squared, minus opposite sign, 2x times 3 is 6x, always positive, 3 times 3 is 9. Okay, let me do one more here. 64 minus 125y cubed. Now, you're not going to change the order of this. You're going to run this problem the same order it's given to you. If you need to change the order, you can do it later after it's in factored form. Let's see what we've got here. So we have got 4 cubed and 5y. So this is going to give us, let's do it. We have 4 minus 5y times 4 times 4 is 16. Change the sign, plus 4 times 5y is 20y. Always positive. 5y times 5y, 25y squared. So I hope this is really a refresher and you have actually seen this. By the way, just as happenstance, just on the side note, just in case you don't know, this is always prime, which means that piece never, ever is factorable in this case. When you use the difference or sum of cubes, that quadratic piece, that piece that has the square in it, never factors. Trust me, I spent 2 years of my undergrad trying to test it, but it doesn't ever factor. Okay, so the next idea that we're brought to is called factoring by grouping. And you've seen seen this before, I'm sure, and this is something very, very true about me, that I might do things just a little slight bit different, and I know that I use some language in my factoring by grouping that you might not be completely familiar with, but I know that it has been very successful for me in teaching students. So let's just do a couple of quick examples. Once you see them, you're going to go, oh yeah, I remember how to do that, and that will be all that there is to that. So the first one, 9x squared minus 6x plus 3x minus 2. Now, when do you use factoring by grouping? You use factoring by grouping when there are 4 terms. Exactly. I don't know why I put that exclamation point there. Exactly 4 terms. That's the only time you use it. Okay, I mean, I guess you could use it if you had 6 terms, but we're not going to be dealing with that kind of situation. So you're going to use factoring by grouping when there's exactly 4 terms. And again, I'm sure that you've already done this before, but I'm just going to talk about it the way that I talk about it. First, you notice that it's 4 terms. You're going to split that sucker in half. And you're only going to focus on the left-hand side. So you look at the first half and you say, what can you factor out? What is the GCF on this left side? And if you take a look, you can see that we can pull a 3x out. And if we pull out 3x, then what are we left with? Well, we're left with a 3x and a minus 2. Now this is where I'm a little bit different than other people. I always call that my twin, and you have to write your twin down again. And then you notice that there's kind of a hole here, and we have to fill the hole with the number to multiply the twin by to get the right-hand side of the equation. Or the expression. Okay, and so if we take a look here, what do we need to multiply 3x by to get 3x? And that is a positive 1. And so our factors now become the twin and the stuff on the outside of the twins. Okay. So let me do another one. Now, you may do this a little bit different way than I do, and that is absolutely fine. I personally know 7 different ways to factor a trinomial. Okay, so it's okay if you do it a different way than I do it. But I'm going to be consistent in the methods that I use so that you always see the same thing from me. But again, I don't really care how you particularly factor, what technique you use to factor something, but you have to factor stuff. Let's take a look at this. 3x squared plus 6x minus x minus 2. Again, you take a look, you're like, oh gosh, this is 4 pieces. I get split it down the middle. I love it when it's 4 pieces. Makes life so much easier. What can we take out of the left-hand side here? It happens that we can take a 3x out. If we take 3x out, we're left with x plus 2 as our twin. And notice I'm going to write that down again. And then we need to fill that hole with what do we need to multiply x plus 2 by to get negative x minus 2, and in this case it's going to be a negative 1. And so here our factors are 3x minus 1, that's the stuff from the outside, and x plus 2. Now we could have written that x plus 2 down first. Remember, it doesn't matter, multiplication doesn't matter what order we do it in. One more example here, and then we'll get to the last big thing, which we've worked up to. Let's take a look at this example. Is 2x cubed plus 4x squared plus 3x plus 6. So first things, we notice it's 4 pieces. 4 pieces, you go straight for factoring by grouping. Let me tell you, it doesn't always work. Okay? Every 4-piece polynomial won't always factor for you, and you're going to learn that when we get to section 5.1. In chapter 5, we're going to start dealing with stuff that doesn't necessarily factor the way that you expect. But right now, it is all pretty. Okay, what can we take out here? We can take a 2 and an x squared out. You want to take the greatest common factor. If you do not take the greatest common factor out, then this trick does not work. So if we take a 2x squared out of here, we're left with x. If we take a 2x squared out of 4x squared, we're left with a plus 2. That's my twin. I'm going to write it down again. Then I want to know, what do I need to multiply x plus 2 by to get 3x plus 6? That would be a positive 3. And so our factors here are going to be our x plus 2. And then whatever's on the outside of the twins, and in this case it's going to be 2x squared plus 3. Okay, excellent. All right, so that gets us to the main crux here, which is the AC method. It is super duper important for you to definitely be able to do the difference of squares without really thinking about it, to factor out the greatest common factor without thinking about it, and also to be able to factor trinomials, which is this AC method that I'm fixing to talk about. So the AC method is one way to factor polynomials in the form of ax squared plus bx plus c, which is usually the form that you're used to thinking about when we start talking about factoring. But notice it's the last one that I'm going to do here because it's important for you to recognize all those other ways as well. Okay, all those other kind of special cases. All right, so the AC method is called the AC method because we're going to use the leading coefficient and the constant to make a list that allows us to rewrite the 3-piece into a 4-piece and group it. Okay, so the AC method, first thing we're going to do is we're going to multiply the A times the C and make a list. Of the factors of that number. Okay, and then after we make that list, then we're going to rewrite the equation or expression. Let me just call it an expression because we're really not solving anything yet. So let me be technical. We rewrite the expression with the pair that sum to be the middle term. Okay, and then finally we factor by grouping. So basically it's just a fancy algebra trick that allows you to do something more easily and get used to that idea, because that is something that happens all the time, and it really, the only reason trig exists is so that we can rewrite problems and solve them more simply, because trig is very portable, so to speak, but we'll learn a lot more about that. Okay, so let's start off with our first equation here. I've got 3x squared plus 10x plus 8. So the first thing that I do is I multiply the 3 times the 8, and 3 times 8 is equal to 24. And I make a list of all the ways to get 24. And if you're not good at factoring, if you always struggle with factoring, then this is the key. The key is when you make the list, you include all the sign possibilities. So this is positive 24. So, and I always make my list in order. I start with 1 and I go to 2, 3, 4. I always do it in order. So I'm going to, how can I get positive 24? Well, positive 1 times positive 24, negative 1 times negative 24. Positive 2 times positive 12, negative 2 times negative 12. Get the idea? 3 times 8, negative 3, negative 8. Oh, sorry, that's an 8. And then I have 4 times 6 and negative 4 times negative 6. So there's my list. And then now what we're to do is to decide what pair off of this list adds to be the number we're looking for. And here we're looking for positive 10. So it looks like we need positive 4 and positive 6. Now what we'll do is we'll rewrite this 10x as positive 4x plus 6x. Now it doesn't matter what order you write that in. I could have wrote the 6x in first. It doesn't really matter. And then I'm going to drop these next two pieces down. Now notice I haven't changed the problem at all. I've just used some algebra trickery, and now we have a 4-piece problem we can factor by grouping. So now I can factor this by grouping by cutting it in half, taking a look at the left hand side. What can we pull out of the left hand side? It looks like we can only take out an x, which is fine and dandy. What does that leave us with? That leaves us with a 3x plus 4 as our twin. I'm going to come over here. I'm going to write down that 3x plus 4 again. And then we need to decide, what do we need to multiply 3x plus 4 by to get 6x plus 8? And that is a positive 2. And so our factors are x plus 2 and our 3x plus 4. So again, I expect that you've seen this, you do this, or you do it in some sort of way. I'm just reminding you and showing you the way that I do it here. So let's do another one here. Let's do our 3x squared minus 14x plus 8. Again, I'm going to say 3 times 8 is equal to positive 24, and the way I get positive 24 is 1 and 24, negative 1, negative 24, 2 and 12, negative 2, negative 12. Once you write down the pair that you know you need, you certainly don't have to write them down. You don't have to write them down at all, but it doesn't hurt to go ahead and get started and have something written down for it. But I see here that I need negative 14, and negative 2 plus negative 12 is negative 14, so I can go ahead and write it here. And I'm going to go ahead and write it like this: minus 12x minus 2x, just So you believe that it doesn't matter what order that we do this in. And let me write these guys down here. It is now 4 pieces, so we can split it. Be careful when you split it. Notice I could have, if I was doing this all with a pencil, I might have split it there and then thought that that was a positive instead of a negative. So do be mindful and careful here. All right, what can we pull out of the left-hand side? Looks like we can take a 3x out. When we take out a 3x, we're going to be left with x minus 4. That's our twin. I'll write that down over here again. And then what do we need to multiply that x minus 4 by to get a negative 2x plus 8, and that will be a negative 2. And so our answer here, our factors are 3x minus 2 and x minus 4. Let me knock out just a couple more here. One more, 6x squared minus 7x minus 5. Take a look at this guy. 6 times negative 5 is negative 30. And I need all the ways to get negative 30, so that's 1 and negative 30, and negative 1 and 30. That's 2 and negative 15, negative 2 and positive 15, 3 and negative 10, negative 3 and 10, 5 and negative 6, negative 6, negative 5, oops, sorry about that, and 6. So this is all the ways to get it, and we're looking for a negative 7. So it looks like 3 and negative 10 is going to give it to us. Notice that here on our other 2 examples, those were positive 24s, because we multiplied 3 times a positive 8, a positive 3 times a positive 8. But here it was 6 times a negative 5, gave us this negative 30. Therefore, our pairs had to have alternating signs. Okay, so here we can put in positive 3x minus 10x and then drop the other 2 pieces down. So we've got our negative 5 here and our 6x squared here. It's 4 pieces, yay. We get to factor it by grouping. Awesome. What can we take out here? We can take a 3x out and we'll be left with a 2x plus 1. Be careful. This is where a lot of people mess up on that. They think that it goes away. It doesn't go away. Remember, you have to be able to multiply it back together to get it all back. What do we need to multiply 2x plus 1 by to get negative 10x minus 5? And that would be a negative 5. And so our factors here are 3x minus 5 and 2x plus 1. Okay, I've just got a couple of mixed examples to do, just a couple more examples to do, but we have now gone over the 5 major types of factoring that you need to be very familiar with to be successful in this class. So this I would call mixed practice. You know, it's impossible for me to show you an example of every problem that you might come in contact with in your homework or on your exams, and certainly as you move forward into your calculus next semester and beyond. So I'm going to try to give you just as many problems for you to be able to get some experience. Therefore, you need to do as many problems as you can to get experience. So here's just a few other problems to do here. 4x squared minus 8x plus 32. I pull this example to make sure that you realize that it's very important for you to always look for the greatest common factor before you factor something out here. And if you notice that we can pull a 4 out of everything here, and we're left with x squared minus 2x plus 8, which I love when I'm factoring when that first leading coefficient is a 1, because it's really easy to factor. How does this guy factor? But if you take a look, 1 times 8 is positive 8. And how can we get that? That's 1 and 8, negative 1, negative 8, 2 and 4, negative 2, negative 4. That's it. This piece right here is what is called prime. It does not factor. So that is as factored as that piece will go. Okay, let's look at another one here. Let's look at this 3y cubed minus 18y squared minus 48y. So taking a look at this one also has that greatest common factor that we need to pull out, and it looks like we can pull a 3 and a y out, and we'll be left with a y squared minus 6y minus 18. Now 18, negative 18, how can we break that down? So negative 18, that's 1 and negative 18, negative 1 and 18, 2 and negative 9, negative 2 and 9, 3 and negative 6, negative 3 and 6. So do any of those work here? 9 and 2 is 7, 18 and 1 is 17. Nope. Again, that's as far as it can go. This piece is prime. Is it? I don't feel like it was when I did my practice problems. Hold on, let me take a look here for a second. It is not prime. Okay, one thing you have to know about me is my arithmetic is terrible. I mean terrible. And this is not 18. Oh no. Oh no. It should be 16. So let me go back here and let me correct my mistake. I try not to erase mistakes. I embrace mistakes, because truth of the matter is I'm going to make mistakes. You're going to make mistakes. Everybody needs to know it's okay to make mistakes. It's not earth-shattering. So anyway, here we go. Negative 16. Let's make the list for negative 16 here. We have 1 and negative 16, negative 1 and 16, 2 and negative 8, negative 2 and 8, 4 and negative 4. Of course, the 4 and negative 4 doesn't work, but the 2 and negative 8 do. And of course, you already knew how this guy factored once I fixed that, because most people are really can more easily factor when that leading coefficient is a 1. They can see that those numbers are going to be y minus 8 and y plus 2. Okay, we're almost done. It's awful late here as well, and I'm just trying to get this first thing recorded and everything, and I just finished mowing my grass and everything. So anyway, it's a mess, but it will get better. But I can't promise I won't make any mistakes, because I will promise you I will do that. Okay, let's look at this guy. Difference in squares, right? Right. Good eye. So this is something squared minus something squared. We're going to recognize that. And in fact, this is x squared squared and 9 squared, in fact. So let's do that formula here. It's first minus last and first plus last. Now, I did this problem to point out a couple things. First off, the sum of squares is not a thing right now. You don't know anything about the sum of squares, and it is, in fact, has no solution in the real number system. Okay, so that means that this piece here, the sum of squares, this is prime. Cannot be broken down anymore. But this guy is the difference in squares again, though, right? This is the difference in squares. That's x squared and 3 squared. So our final factoring here is going to be x minus 3, x plus 3, and then this guy is still part of the answer, x squared plus 9. And then I have one last kind of crazy example to leave you with, to make you kind of think. This guy here, 3 times x squared plus 10x plus 25 minus 4 times x plus 5. Now, this problem is kind of designed for you to recognize some patterns here. And if you've been factoring very much, if you know much about factoring, then you do know how to see that x squared plus 10x plus 25 is x plus 5 quantity squared. It fits a pattern. And if you don't already know that pattern, that's okay. But this question just depends on you recognizing that pattern. You could multiply this through and get it all together to be a brand new problem and then factor it from there. But here it's depending on the fact that you know that x squared plus 10x plus 25 follows this pattern of x squared plus 2 I should have done it with an f here. F squared plus 2 FL plus L squared is equal to F plus L squared. But if you don't commonly know that, that's okay. But this is something that you have most definitely studied before you got here to me. So I'm not being completely nuts by suggesting that you might recognize that. Okay, and now here you can just factor, common factor here. And what's common is the x plus 5. And that leaves us with 3 times one of the x plus 5s minus that 4. And then we can clean this up. That's 3x plus 15 minus 4 gives us 3x plus 11. Okay, so this was a little bit unique because this lecture and the next lecture, so the first 2 lectures are a little bit out of sorts, not quite normal, and it's going to feel very reviewy because it's very reviewy. All right, and then we'll get going. Thank you so much. You guys have a good night.